As we have the opportunity right now, let's take a look at how the documentation of getSTD handle looks like. I open my browser, and next I'm going to msdn.com. Now I search for getSTD handle. And I pick the first result. I get this page about getSTD handle function. Let's take a look at the syntax of this function. It seems like it takes only one argument, which is called std handle. It says that this parameter can be one of the following values: std input handle, which is really -10, std output handle, which is -11, and std error handle, which is -12. As explained here, std input handle is the standard input device. Initially, this is the console input buffer. In the same way, std output handle is the standard output device. Let's take a look at the return value. It says that if the function succeeds, the return value is a handle to the specified device. If the function fails, it has a specific return value, which is invalid handle value. In our code, we didn't check it because we wanted to keep the code simple. However, if you write production code, you will have to check the return value to make sure that no error has occurred during the call to getSTD handle. There are more explanations here about this function, and finally we can see that it is inside kernel32.dll. Let's minimize this window. I want to discuss a bit more about what we see here with the getSTD handle function. You might be wondering, where did we define this constant, std input handle? Let's try to search it inside this program. It seems like this is the only place where we can find this constant. So this is a bit mysterious. How come we have this constant if we didn't define it anywhere? As you've probably guessed, this constant is defined inside win32a.inc. I want to show you how it is defined. At least once we can see how some constant defined inside win32a.inc. This way, if you ever want to search for some constant inside win32a.inc, you will know how to search. In this side, I have the fastenW directory. This directory is just the location where I installed fasten. Next, I'm going to take a look at the include folder, which contains win32a.inc. If I open this file, I can see that basically it just includes a few other files. The file that we care about at this point is this one, include equates kernel32.inc. This is where we are probably going to find the constant that we look for. I close this file, and next I go to the equates folder. Here I can find kernel32.inc. Let's open this file. I remind you that I am looking for this constant, std input handle. Let's search for it. We see that we can find it here. Just like specified in the MSDN documentation, it equals -10. We also have here std output handle and std arrow handle. As you have seen inside this file, there were many more constants defined inside win32a.inc. Most of the time, whenever you see a constant in MSDN, it is probably defined somewhere inside win32a.inc. And if it is not, you could define it yourself in your program. I also want to take a look at read file in the MSDN documentation. Let's take a look. Read file. I pick the first result. And I get here this page about the read file function. There is a general explanation here. Read data from the specified file or input-output device. Interesting. It means that we can also use read file to read from files and not only from the console as we do in our program. Let's see the arguments, or as they call it in MSDN, the parameters. The first one is the file, the handle to the file. The next one is the buffer, followed by number of bytes to read, and then number of bytes read. Note that this argument, number of bytes to read, is specified as input argument. However, the next one, number of bytes read, is specified as output. That is because we use this argument to get output about the operation of this function. However, this number is given as input. Let's read just a little bit about the parameters. The first one, hfile, is a handle to the device. Next one, lpbuffer, is a pointer to the buffer that receives the data. Number of bytes to read, as we have seen in our program, is the maximum number of bytes to be read. Next we have number of bytes read, which is the out argument. As it says here, it is a pointer to the variable that receives the number of bytes read when using this function. By pointer, it means that you should give an address of some location in memory. This is how high-level programmers call addresses. It also says that you could specify null, which is just 0, and then you will not get anything from this argument. For example, if you do not want to know the amount of bytes read, you could just supply the value null. Next, there is the last argument, which is the optional one. We can see that it says here, optional. We chose to put null or 0 inside this argument. write file is pretty much the same as read file, at least in the documentation. Therefore, just make sure to read the documentation of write file later, after we finish with this video. Let's try to debug using WinDBG console echo.exe to get more insight about the console echo program. First, let's make sure that we have console echo open so we can see the code anytime that we want. Next, we open WinDBG. I copy the path, paste it here, and I pick console echo.exe. I got here console echo.exe in a powered state, and I got the command line of the debugger waiting for commands. Let's begin as usual by putting a breakpoint on the entry point. Next, we use the go command to get to the first instruction. Let's open the disassembly window to view more instructions. As we can see, the first instruction is push, followed by call, and then move, just like in our code. Push, followed by call, and then move. This is basically push std input handler. Let's step a bit and find out what is the output of get std handler. I'm going to use step over because I do not want to get inside get std handler. In fact, it will be very unfortunate if I do get inside get std handler. I click step over, and again, this is right before we invoke the get std handler function. We click it again, and now we are supposed to have inside EAX the result of this function. Let's view the contents of EAX. It has the value 3. Basically, this is what we got as a return value from this function. And this is what is going to be stored into the dword input handler. Let's try the second call to get std handler. It is interesting to know what will be the value this time. This is right before the call to get std handler. We step over. Now let's take a look at the value inside EAX. It is 7. So the first one was 3, and the next one is 7. The value 7 will be stored into output handler. Let's continue a bit to the call to read file. We have to step over many push instructions until we get to the actual call instruction, which is really this instruction here. There are some interesting things that we can check at this point. First, we have here the addresses which we put as arguments to this function, which is very convenient. We can see, for example, the address of input star by looking at this instruction. This number is really the address of input star. We can use the db command to view the current contents of input star just before we call the read file function. We can see that it only contains zeros. And this is kind of expected. it is inside the BSS section, which is the uninitialized data section. We can also take a look at bytes read. By looking at the disassembly view here, we can see that it is in this address. Let's copy this address and view the contents of this address. We can see that currently it contains 0, which is also expected. Bytes read is also in the BSS section. Now let's invoke the read file function and see how those two values change. I use the step over, of course, because I just want to invoke this function and not debug this function. As you can see, the debugger says that it is busy. That is because the program waits for input. At this point we should supply some input. Let's give it, for example, the string hello world. Now I press the return key. At this point, the debugger has waken up. And we got to the next instruction, which is push 0. Let's check the contents of input star and bytes read at this point. We can just use the up arrow key to get to the previous commands in the debugger. This is the command which we used to read input star. I press the return key and we can see that now it contains hello world. Some interesting thing to note is that it also contains the new line characters D and A. It means that read file has also taken my return key press as input. Maybe some other information about read file. It will probably be useful for you to know that it does not add a null terminator. If there was no 0 here previously, the read file function will not bother to put a 0 terminator in the end of the string. That is because read file does not really care about strings. It only reads bytes as buffers. If you ever want to use a string that you read from read file, make sure to put the 0 terminator yourself. You could find, for example, where to put the 0 terminator by checking out the value of bytes read. Let's find out what is the value of bytes read. We can again use the up arrow key to get one of the previous commands. In this command, we previously read the value of bytes read. Let's see what it contains now. This time it contains 14 in base 10, or maybe E in base 16. Let's count for a moment. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Exactly 14 characters, including the 2 characters which are the new line sequence. Note that hello world was not yet echoed to the console. If we use the G command at this point to let the program resume, we expect it to be printed. I use the G command and press the return key. And as expected, hello world was echoed to the console. At this point we can close the debugger. Let's wrap up the discussion about the program console echo.asm. In this lesson we learned to input and output to the console. using the functions getStdHandle, readFile, and writeFile. We have seen that we first have to acquire a handle to the input and also a handle to the output. This is done using two calls to getStdHandle. Only then we could use readFile and writeFile. We use readFile to read from the input handle and writeFile to write to the output handle. Make sure to check out writeFile in MSDN and try to understand the documentation for this function. It is really pretty much the same as readFile.